So we're going to talk about galvanic cells. What happens in a galvanic cell is the transferring of electrons. In this case, electrons will flow from zinc towards copper 2. So it will lose 2 electrons due to the reason that copper 2 is asking for 2 electrons. This means that copper 2 plus would be part of our, okay, which means since this side is gaining electrons, this would also be considered our reduction side, which is also known as a cathode, which means that because this is losing electrons, it means that it's also being oxidated, which is also known as our anode.
So the ion having the greater attraction for electrons would be the copper 2 plus because it has a stronger standard reduction potential volt, which is 0.342. So oxidation reduction reactions could be divided into half reactions to get a better picture of the electron transfer process. So the oxidation and reduction process, they each occur in different physical locations. So the oxidation would be in the anode side. So we would be getting zinc, yielding zinc 2 plus 2 electrons. And then for the reduction, it would be the copper 2 plus 2 electrons giving us copper. So once we combine those two equations, we get this overall equation, which is zinc plus copper 2 plus yielding zinc 2 plus copper.
Okay, so let's talk about what happens when cobalt replaces zinc electrode here, and the reaction is almost the same. The electrons flows from cobalt up to the copper shell, and eventually it is gained by copper 2 ions. And so we can know that the half reaction here is cobalt lose the electrons and become cobalt ions, and copper 2 ions gains the electrons and become copper. The difference is that this time the voltage is 0.62 volts, and in the previous experiment we have a voltage of 1.10 volts. That means when copper cell is connected with a cobalt cell, the electron has a stronger standard reduction potential than zinc. So we know that cobalt 2 ions has a stronger affinity for electrons than zinc ions. As a result, we have a lower voltage here than we have when the copper cell is connected with zinc cell.
Well, this is the model of a standard hydrogen electrode, which is also known for a sheet. Right here, it shows how the hydrogen 2 gas transfers through the anode here and goes into the solution of hydrogen plus. Right here is the general half reaction of the hydrogen equation, which is 2 electrons plus 2H plus, which creates the hydrogen gas. And right here, when we
Hey guys, sorry about that little mishap. What Matthew was going to finish off saying was that copper 2 plus is a stronger oxidizing agent as compared to hydrogen plus due to the fact that it has a higher assigned standard reduction potential. So yeah.